Now we're going to apply the same techniques that we did for the potential that is not at the center, 3 meters away. We're going to apply similar techniques to find the electric field 3 meters away. How do you do that? Okay. We know the electric field at the center of the semicircle is 2kq over pi r squared from previous videos. Okay. So the electric field should be 9 times 10 to the 9th. So it's a 2 meter radius rod. So 4 times 10 to the minus 9 over pi times 2 squared. So what is the electric field going to be at the center? 10 to the minus 9, 10 to the minus 9 cancel. You have E center 18. 2 times 9 is 18. 2 squared and 4. 4 and 4 cancel. 18 over pi. So let's calculate that. .73 newtons per coulomb. So the electric field at the center is 5.73. So let's see what the electric field there is going to be. We expect it to be weaker, right, than 5.73. Okay, so how do we do that? Well, we do it similarly to how we did the potential. Okay, so we have a certain element of charge. But except that this one has a direction. That element, the dq, which equals to lambda dx prime, where x prime is defined as this distance. This is x, this is r. That element creates an electric field pointing away, dE, right? Then we use symmetry. We take the potential, we take another element here, and then that one creates a electric field this way. Then we define this as angle alpha, so only the x component of the electric field survives. Okay, so we have dE total equals 2dE cosine alpha. Right? So when we do the integral, we're only going to integrate over half of the rod. Right? Then you're going to have 2k dq over r squared cosine alpha. Right? And then we can use the same equation for r that we had from the previous potential. We had here r, we had here x. Remember, r squared was equal to r squared plus x squared plus 2rx cosine theta, where this is theta. Okay, so I am getting that from the previous derivation from the law of cosines. So it's pretty much the same thing, r squared x squared 2rx cosine theta. That one is what goes here. The extra thing that we have here is cosine alpha. So somehow we have to relate this alpha and this angle theta together in a certain way. How do we do that? So now law of sines is going to come in handy. If this is alpha, this is alpha, this is also alpha. So let's enlarge that. So let's draw the electric field strength here, 5.73 newtons per coulomb. So let's draw that triangle. Okay, so this is 180 minus theta, this is alpha, right? This angle alpha and alpha are the same, right? And this is r, this is x, this is r. So we're going to say sine of alpha okay, so we're going to say sine of alpha over r is equal to sine of 180 minus theta over that r, right? Now sine of 180 minus theta is the same thing as sine of theta, so we can just replace that. So we have sine of alpha, cross multiply, we have big R over R, sine of theta. right? So sine of alpha is big R over little r. So far that's so good. But the problem is I have cosine alpha here, right? The electric field depends on the x component of the dE. The x component is dE cosine of alpha. So if sine of alpha is this, then what's cosine of alpha? Well, we use a trick from trig, right? If alpha is a certain angle, right? It's just a certain angle in the unit circle. And let's say alpha is a certain angle such that its sine is equal to what? R sine theta r, right? So imagine a triangle where this is 90 degrees, and then imagine sine of alpha, the opposite side is r sine theta, and the hypotenuse of that triangle is r, right? Now you might be saying, well, alpha is not really 90 degrees, how can you make it 90? This one I'm trying to just envision what the angle alpha would look like in a triangle that is 90 degrees, right? If the triangle is 90 here, sine of alpha would be r sine theta, and then the hypotenuse of that triangle will be little r, right? What would the cosine of alpha be? Cosine of alpha, well, we need to know what this side is, right? Square root of r squared minus this squared, right? So what would cosine of alpha be? Cosine of alpha would be this over this. That's what basically goes over here, right? Cosine of alpha is that over that. So let's put that in. Square root of r squared minus r squared sine squared theta divided by r. So it'll be what? Basically, the denominator here turns out to be r cubed, right? R squared times r, so r cubed. So we're almost there into making this integrable, right? Now we use this equation. R squared is r squared plus x squared 2rx. We put that equation into here. Okay? So you see where r squared, you're going to put that. R squared plus x squared plus 2rx cosine theta, right? Minus r squared sine squared. Minus r squared sine squared theta. So this r squared is coming from here, okay? And then this one is coming from here. And then on the bottom you have what? R cubed. And r cubed is basically what? You square root this, right? And then you want to cube it, it'll be 3/2 power, okay? So it'll be r squared plus x squared plus 2rx cosine theta 3/2 power. We can simplify this one step further. Notice over here we have r squared minus r squared sine squared. What is that? R squared minus r squared sine squared. Well, you can factor out the r squared. 1 minus sine squared is cosine squared. So you have here r squared cosine squared. Okay? So your final simplified version, dE equals 2k dq square root. This turns out to be r squared cosine squared plus x squared plus 2rx cosine theta, all under a radical, right? Divided by this thing, r squared plus x squared plus 2rx cosine theta to the 3/2 power. Now we can integrate this. dq is equal to lambda dx, lambda dx prime, 2k lambda comes out of the integral if it's a uniform charge density, so it just becomes q over L 2kq over L. dx prime is what? If x prime is equal to r d theta, if x prime is equal to r theta, dx prime is equal to r d theta. So same as when we did the potential. So you have here 2k lambda q over L, dx prime is equal to r, and then d theta stays in the integral. So d theta, square root of this whole thing, over this thing. The top and the bottom look pretty similar. You got the r squared, you got r squared, but except you have x cosine squared theta. You have x squared, you have x squared. You have 2rx, you have 2rx cosine theta. And now we're going to integrate this 0 to pi over 2. Remember, we're only going to integrate over half of the rod. If our equation is correct, and I put here x equals 0, what should happen? Okay?